What you see here is an end-on picture of a beam attempting to balance on a magic marker. Here's a beam. You move it to its end, to where you're looking at the end, and put it over here. And then you put a magic marker under it. And that's what the picture's attempting to show you. Here's the marker. Well, yeah, get my hand in the way. Here's the marker, the top of the marker. And here's the end view of the beam. Now, you see that when the beam rotates, its center of mass, which is right here, it's along an axis coming out of the end, and it's directly over the marker. That center of mass, as we rotate the beam this way, will move with the axis of the beam, and it'll very quickly move outside the edge of the top. In which case, then, we're going to have a torque that's going to tend to accelerate the beam more in this direction, and the beam will just tend to accelerate and fall right off the ramp. Now when we draw this, we draw the central axis, and then we draw the beam at the center. The central axis goes right through the center of the cap of the magic marker here. Here it's starting to rotate out a little bit to this side of the cap, but the center of mass rotates even more in this direction, and again very quickly gets outside the center of the cap, and that's why this balance is so precarious. Now if we tape some markers represented by this green rectangle here with its center of mass beneath the beam with its center of mass, then what happens when we attempt to rotate the system? Well, as we rotate the system, the center of mass of the beam moves out this way. Remember, the central axis here is going to rotate. It's vertical here, and as the central axis rotates, anything above the center of the, or anything above the top of the cap here on which the thing is balancing is going to rotate this way. Anything below the cap is going to rotate this way. So the point is that the center of mass of the beam rotates in this direction and quickly goes outside the edge of the cap, but the center mass of the washers rotates in the opposite direction, and if the washers are massive enough, then when you combine the torque here with the torque here, it is not sufficient to cause an acceleration in this direction. It's actually going to accelerate the system back toward the center, toward stability. Now you can imagine, I haven't drawn it, but you can imagine that if the markers were on top of the beam, okay, imagine the markers up here, you can see that, not the markers, the washers, if the washers are on top of the beam, then their center mass is going to rotate out this way even further than the center mass of the beam. And that's going to make the system much more unstable than just the beam by itself. So if we compare, we have the most stable situation here with the washers taped under the beam. The least stable is with the washers taped on top of the beam, and the beam by itself with no washers is intermediate in stability.